A very good morning to one and all. Myself, Dr. Rishabh Gupta, and in today's session, we will be conducting a Z test in MS Excel. So let's begin. The question is that is there enough evidence at alpha is equals to 5% to conclude that the population mean age differs significantly from 46 based upon the following sample. Assume population standard deviation equals to 5. So this is my data set, and based upon this data set I need to calculate the Z test in MS Excel. So let me first copy paste this information, Control C and Control V. Now in order to conduct the Z test, first and foremost I need to create my null hypothesis as well as the alternate hypothesis. The null hypothesis is represented by HO. So in order to activate the subscript, let me first click on this icon and then you need to click on subscript and then OK. That is HO. So the HO is equals to 46. And the next is the alternate hypothesis, which is represented by H1. So again, click on format cells and then activate the subscript. This is not equals to. You can find the not equals to sign under the mathematical operators. Click on insert and then close. So in this way I have created my null hypothesis as well as the alternate hypothesis. It's a case of a two-tailed test. So since my data analysis package only contains an option of two sample Z tests, so we need to create a dummy variable. Now let me note it down the value of 0. Why we have created this dummy column? In the data analysis Toolpack, there is only an option of two sample Z tests. Now after the creation of null and the alternate hypothesis, let's understand that how we can conduct the Z test in MS Excel. Now go to data and then click on data analysis tool package. There is an option called two sample for means. Click OK. First and foremost you need to select the variable one range value. So the variable one range value starts from here. So I have also selected the age as well as my heading. Similarly for the dummy variable it is these two cells, that is B1 and B2. The hypothesis mean difference is 46 in this case. Mean variance for age is 25 while the variance for variable 2 is 0. Since if I will write 0 over here, then my output will show an error. So instead of writing 0, I have write a value that is very close to 0, that is 0.0001. Let me checklist this box as well. Labels. Alpha is 0.05 and I wish to represent my output in C4 and then click OK. Now let me make a small modification in this output. Instead of one sample Z test for mean, we have one sample for mean. The hypothesized mean is 46 in this case. And now I can also eliminate this column of dummy variable. Now let's understand these variables one by one. Now this mean age is 43.89 and I need to check using Z test that whether this mean age is statistically significant or not. The known variance is 25, number of observation is 35, the hypothesized mean is 46 and this Z is minus 2.501. This Z represents my Z statistics. Now we have P1 tail and P2 tail. Since it's a case of two-tail test, now I only need to focus on P value of two-tail test as well as the Z critical value of two-tailed test. Now there is a simple rule to identify that whether my hypothesis is rejected or not rejected, and the rule is that if the p-value is less than alpha, then we reject the null hypothesis, and vice versa. Alternatively, there is another way for identifying the rejection or non-rejection of null hypothesis, that is by comparing your Z statistics with Z critical value. In this case, I can see that the p-value of two-tailed test is 1.2%, which is less than the level of significance of 5%. Hence, we reject the null hypothesis. Alternatively, I can also check the Z statistics. Since the Z statistics is minus 2.501 in this case, which falls into the rejection area. So the Z statistics is less than minus 1.96. The Z critical value of two-tailed test is minus 1.96 to plus 1.96. Now in this case, my Z statistics of minus 2.501 is less than the Z critical value. Hence, we will reject the null hypothesis. And the null hypothesis is that the mean age difference is equals to 46. So there is enough evidence to conclude that the population mean differs significantly from the mean age of 46. Since it was a case of a two-tailed test, in single-tailed test or in a one-tailed test, there will be only two changes. And the two changes are, first you need to reframe your null and the alternate hypothesis, number one. Secondly, you need to compare the p-value of one-tailed test, or you need to compare the Z statistics with the Z critical one-tailed test if it's a case of single or one-tailed test. We all know that the one-tailed test includes your right-tailed test as well as the left-tailed test. I have also mentioned few examples of right-tail and left-tail test. Following the same example with a small modification, I can say that is there enough evidence to conclude that the population mean age significantly greater from 46 based upon the following sample, assuming population standard deviation of 5. Now in this case, this is a case of right-tail test. Now under the right-tail test, my null hypothesis will be equals to 46 and the alternate hypothesis will be greater than 46. The next is your example of left-tail test. Is there enough evidence at alpha is equals to 5% to conclude that the population mean age significantly lesser than 46 based upon the following sample, assume population standard deviation of 5. Now again in this case also, my alternate hypothesis will be H1 less than 46 and my null hypothesis will be greater than equals to 46. So that's all from my side. We'll meet you in my next session. Have a nice day.